are going to see about what is workability and how they both are related to each other. Let us begin with what workability means. Workability is defined as the ease with which concrete can be compacted to 100%. 100% compaction contributes to the maximum strength of concrete. Lack of this 100% compaction leads to air voids, which reduces the strength and durability of the structures. Workability, in other words, is the consistency with which concrete can flow with less compaction and without any loss of its properties. It is the degree of mobility or fluidity of concrete with which it can flow when placed from the pan or the mixer. Workability of concrete can be attained only by trial and error methods, and there are no specific codes to be followed to attain workability. To enable 100% compaction, usually a high water cement ratio is required. The function of water is to lubricate concrete so that concrete can be compacted with less effort. The water lubrication also helps in handling concrete without segregation, placing them without any loss of homogeneity, and in finishing process easily. There are various types of workable concrete such as unworkable concrete, medium workable concrete, and highly workable concrete. Unworkable concrete can also be called as harsh concrete. It is a concrete with very little amount of water and difficult with hand mixing. Such type of concrete has high segregation of aggregates as cement paste is not lubricated properly to stick to the aggregates. It is very difficult to maintain the homogeneity of concrete mix, and compaction of concrete requires much more effort. Water cement ratio is below zero point 0.4 for such concretes. Medium workable concrete. This type of concrete workability is used in most of the construction works as it is easy to mix, transport, place, and compact without much segregation and loss of homogeneity. This type of concrete workability is generally used in all constructions with light reinforcement. Spacing of reinforcement allows the concrete to be compacted effectively. Water cement ratio for medium workable concrete is between zero point 0.4 and 0.55. Highly workable concrete. Highly workable concrete is very easy to mix, transport, place, and compact in structures. Such concrete is used where effective compaction of concrete is not possible or in mass concretes. Such concrete flow easily and settle down without much effort. These concretes is used in case of heavy reinforcements where vibration of concrete is not possible. Example of highly workable concrete is self-compacting concrete. Water cement ratio of this concrete is more than 0.55. Workability requirement of concrete varies with each type of construction works and compaction methods used. For example, concrete which is considered workable for roof constructions cannot be considered workable for mass concrete foundations. Workability requirement when vibrators are used for constructions are different from when vibrators are not used. From the figure, it is evident that strength of concrete decreases with increase in water cement ratio. The increase in water cement ratio indicates increase in workability of concrete. Thus, strength of concrete is inversely proportional to workability of concrete. Section, size, amount, and spacing of reinforcement has effect on workability. When a section is narrow, highly workable concrete is desirable to obtain full compaction through a reasonable amount of effort. When the section is crowded with steel reinforcements and spacing of bars is relatively small, compaction can be difficult and hence highly workable concrete is recommended in such cases. Aggregate cement ratio is also an important factor affecting workability. Greater the aggregate cement ratio, the leaner is the concrete. Leaner concrete provides much less paste for lubrication per unit surface area of aggregates, which restrains the mobility. In rich concrete with low aggregate cement ratio, more paste is available to make mix cohesive and fatty to give better workability. When the aggregates are of bigger size and rounded shape with smooth texture, there is less surface area and less voids. Hence, less water and paste is required for lubricating the surface, which provides greater workability and reduces frictional resistance. When coming to the factor of grading of aggregates, the better the grading, less is the void content, which have excess paste available to give better lubricating effect, which in turn gives higher workability. Use of chemical admixtures and air entraining agents also increases workability. Use of fine pozzolanic materials also have better lubricating effect and more workability. Weather conditions also influences the workability of concrete. If temperature is high, evaporation increases, thus workability decreases. If wind is moving with greater velocity, the rate of evaporation also increases, reducing the amount of water required for lubrication, which ultimately reduces workability. Till now, we have seen how various factors affect workability of concrete. Let's see how to enhance the workability. Workability can be upgraded with the use of large-sized, well-rounded, smooth and non-porous aggregates. It can also be developed by increasing the water-cement ratio and adding air-entraining admixtures. As workability is a complex property of concrete, it must be definitely measured. Usually, workability is measured in the laboratories. As changes can occur in workability during transportation, workability is measured again at the sites. The lab tests include compaction factor test, VB consistometer test, and the flow test. Flow test is usually done for calculating the workability of self-compacting concrete. Generally, slump test and Kelly ball tests are conducted at the sites to measure the workability of concrete. Slump test is the most commonly used method of measuring consistency of concrete, which can be carried out either in laboratory or at the site of work. It is not a suitable method for very wet or very dry concrete. This table shows the degree of workability and its corresponding usages. Usually, a concrete with very low workability is suitable for roads that are vibrated with power operated machines. A low workability concrete may have slump value from 25 to 75 mm, which can be used for mass concrete foundations without vibrations or lightly reinforced sections with vibrations. A medium workable concrete will have slump value of 50 to 100 mm. This type of concrete can be used in normal reinforced concrete and heavily reinforced sections with vibrations. A high workable concrete consists of slump value of 100 to 150 mm, which can be used in the sections of congested reinforcements. It is done by pumping and tremie placing. The test apparatus consists of a metallic mold in the form of a frustum of a cone. The mold is filled with four layers, each being approximately one-fourth of the height of the mold. Each layer is tamped 25 times using a tamping rod. The excess concrete is struck off with a trowel. The mold is removed from the concrete immediately by raising it slowly and carefully in a vertical direction. This allows the concrete to subside. This subsidence is referred as slump of concrete. The difference in level between the height of the mold and that of the highest point of the subsided concrete is measured. This difference in height in mm is taken as slump of concrete. There are various patterns of slump. It indicates the characteristics of concrete in addition to the slump value. If the concrete slumps evenly, then it is called a true slump. If one half of the cone slides down, then it is called a shear slump. In this case, the slump value is measured as the difference in height of mold and the average value of subsidence. It also shows that concrete is non-cohesive and indicates segregation characteristics. If cone spreads, then it is called a collapse slump. Slump test is very useful on the site to check the day-to-day variations in the materials being fed into the mixer. An increase in slump may mean either moisture content of aggregates has increased unexpectedly or grading of aggregates has changed due to the deficiency in sand. Thus, too high or too low slump gives a warning to the mixer operator to remedy the situation. The last test is Kelly ball test. It is a simple test performed at the sites. The test has been devised by Kelly and hence known as Kelly ball test. The apparatus involves a metal hemisphere ball of 15 cm diameter weighing 13.6 kg attached to a stem with a handle which is placed on the fresh concrete. The concrete sample is taken in a container such that minimum depth of concrete must be at least 20 cm and the minimum distance from the center of ball to the nearest edge of concrete must be 23 cm. Once the concrete is filled, the surface of concrete is leveled off. The setup is kept on concrete by holding the handle of hemisphere such that the frame touches the surface of concrete. Now the ball is released on the surface of concrete. Then depth of penetration is read immediately on the stem to the nearest 6 mm. Similarly, another two measurements are made on the sample and average is taken as the slump value. The advantages of this test is that it can be performed on concrete placed inside, and it is claimed that this test can be performed faster with a greater precision than slump test. The disadvantages are that it requires a larger sample of concrete and it cannot be used when concrete is placed in thin sections. Let us discuss the laboratory tests and the admixtures used to attain workability of concrete in the next upcoming video. Until then, stay tuned. Thank you.